Okay, hi guys, can you hear me? Okay, great. So for any question, I have muted you, so if for any question, just write in the chat and I will answer all the questions. So let's start. You received the agenda. We have 3 scenarios, maybe 4, and then I will sum up. Yeah, sure, thanks Varun. I'm recording the session. So, and at the end, I will sum up what you need to know for the exam. So first question is a sample final exam version 1 part 2. This is a game theory exercise. So we have consider a one-shot simultaneous move game in which player A can choose between the strategies fight or share. And player B also can choose between the strategies fight or share. The payoffs for the various combination of choices are shown below, and both players know that these are the payoffs. So let's write down our matrix. So we have a 2 by 2 matrix with player B that is the row player and player B is the column player and A is the row player. And every player has 2 possible actions, that is fight, F, or share, S. And the same for B, fight or share. The payoffs are, if they both fight, A is gonna get 140 and B is gonna get 100. If A fights and B share, A gets 210 and B gets 80. If player A is gonna share and B fights, A gets 110 and B gets 190. And finally, if they both share, A gets 180 and B gets 170. So in the matrix, always remember that the first payoff in the box is associated with the row player, here is A, and the second payoff in each box is associated with the column player, that is B. Okay? So now part A says, there are either 1 or 2 Nash equilibriums for this game. If there is 1 Nash equilibrium, what is it? Or if there are 2, what are these 2 Nash equilibria? Explain clearly why you reach this conclusion. So, what is a Nash equilibrium? A Nash equilibrium is a box where you have an arrow for each player coming in. So, Nash equilibrium is the box where you have one arrow for each player So let's see here what happens. Let's start from player A. We have basically to consider 2 possible scenarios. What A would prefer to do if B were playing fight, and what A prefer to do if B plays share. So if B plays fight, A can choose fight and get 140, or share and get 110. 140 is greater than 110, so we have an arrow going from share to fight for player A. The second possible scenario is that B chooses share. Then what is the best for A? If it plays share, he will get 180. If he plays fight, he gets 210. So since 210 is greater than 180, we have an arrow going from share to fight. So, as you can see here, for player A, it's better always to fight. So no matter what B will do, A want to fight. This situation where for one player it's better to do one particular action no matter what the other does is called a dominant action. So a dominant action is that action that no matter what the other player does, you always want to play that action. So here again, as you can see, A will prefer to fight if B fights or if B share. So no matter what is the decision of B, A will always choose fight. Okay? So here F is dominant action for player A. Any question on dominant action? Okay, so now let's do the same analysis for player B because we want to find the Nash equilibrium. So now there are two possible scenarios in which B could be. The first one is when A plays fight and the other one is when A plays share. So if A plays fight, what does B prefer? B will compare the payoff of 100 from fight with 80 from share. Since 100 is greater than 80, we have an arrow going from share to fight for player B. And if instead A chooses to share, then B will compare the payoffs of 170 from sharing with 190 from fight. Since 190 is greater than 170, we have an arrow going from share to fight. So again, now I have a question for you. Do you see a dominant action for player B? So as you can see, exactly, Lille. So basically, also for player B, it's better to fight no matter what player A does. He will be, no matter what player A does, will get more if he plays fight instead of sharing. So here we have that F is also dominant action for B. And now let's go to C. What are or is the Nash equilibrium? We need to find the box where we have one arrow for each player coming in. And here the only box that has such property is fight, fight. So our unique Nash equilibrium is fight for both players. So this will be our Nash equilibrium. For every other box, as you can see, you have one arrow going in but one arrow going out, and so you don't have any other Nash equilibrium. Any question? So my advice in this kind of exercise that is pretty easy is not to compare the wrong payoffs. Okay, so always compare the right payoffs among each other. So basically, for the raw player, you will compare these two payoffs, one with each other, and you'll see which one is greater. And then you will compare these two payoffs, and you see which one is greater. For the column player, you will compare these two payoffs, and you see which one is greater, and these two payoffs, and you see which one is greater. Okay? So this is the only tricky thing in this kind of exercises, not comparing the right numbers. Okay? Questions? Okay, so let's move to part B. Yeah, so Sasha is asking what is dominant for A. For A is dominant to fight, because no matter what B does, he will always prefer to fight because it gives him higher payoff than share. Other questions? Okay, so part B. Part B says, both players now realize that player A actually has a third possible strategy, waffle. Player B still has the two strategies. Here is the new game, but the payoffs for the strategy row waffle are not yet known. So basically now we have player A who can choose among three possible strategies, and player B that can still choose only among those between those old two strategies. And we don't know what is the payoff, what are the payoffs for A and B from A playing the strategy waffle. The question says you are asked to indicate numerical values for the payoffs for the new row, so that in this modified game there is no Nash equilibrium. What are the payoff values that you choose? Explain why there is no Nash equilibrium. So basically here we want to find numbers, payoffs, such that we do not have any Nash equilibrium in pure strategies in the game. So let's see how to modify it. I'm gonna write down the matrix again. Now we have three possible actions for player A, that is fight, waffle, and share, and only two possible actions for player B, that is fight or share. The payoffs are the same as above for fight, that is 140 for A and 100 for B. Then we have 210 if A fights and B share, and 80 for B. We don't know what happens when A chooses waffle, and when A chooses share and B chooses fight, we have 110 for A and 190 for B as before. And if they both share, we have 180 for A and 170 for B. So here we want to find the payoffs for basically when A chooses waffle and B chooses fight or share, such that we do not have any Nash equilibrium. I will call these unknown numbers with the letters. So we have an X here that is the payoff we want to find for A when he chooses waffle and B chooses fight, and Y is the payoff for B when A chooses waffle and B chooses fight. Then we have Z for A if he chooses waffle but B chooses share, and we have, let's call it a delta, the payoff for B if A chooses waffle and B chooses share. So we want to modify the game. We want to find a number such that these X, Y, Z, and delta, such that there is no Nash equilibrium. So first of all, if A chooses to fight, B will compare 180. So we can already say what B would do in the scenario where A chooses fight. Since 100 is greater than 80, as before, we know that B prefers to fight. And here is the same as before, right? And if A chooses share, then B will compare 190 from fight with 170 from share. So again, as before, B prefers to fight, right? So the first step is to draw the arrows for those boxes and for that player who already have all the numbers in it. We cannot do anything, we cannot say anything for now on what B will choose between fight and share when A waffles, because we don't know the numbers for Y and delta. We have to find them, okay? So the first step is to draw the arrows for B when A chooses fight and when A chooses share. The second step is, let's think at part A. In part A, we had the Nash equilibrium. The Nash equilibrium was fight, fight. So basically, we had this arrow going out from 110 and going up to fight. We do not want that anymore, because if we have an arrow going in to fight, fight, we will have a Nash equilibrium, right? Because we already have an arrow going in from 80 to 100 for player B. So we want the number x to be greater than 140. So if x is greater than 140, then we have what? That A will prefer to waffle. So again, what is the logic for this? Since we already have, do you remember that in part A we had that fight, fight was a Nash equilibrium? And we already have this red arrow going in from 80 to 100. We do not want an arrow also for player A to get into the box fight, fight. Otherwise, we would have again the same Nash equilibrium as before. Okay, so we want now that x is greater than 140. So our arrow for player A will go to waffle in case B chooses fight. Okay, so we killed the Nash equilibrium that we had in part A. So now what is the next step? Now that we have this arrow going in the box waffle fight, that is the arrow going in for player A to x, we do not want, in case player A chooses waffle, player B to choose fight, because if we had that, we would have an Nash equilibrium, right? I'm talking about this box. So we already have an arrow coming in for A. We do not want an arrow coming in for B. So basically we need an arrow going out from here. So we need y smaller than delta. So that we have that B chooses share when A chooses waffle. Right? So that we killed the possibility of a Nash equilibrium in the box waffle fight. Question on this? So what is the final step? What arrows are we missing? Basically, we need to find what A is going to do when B chooses share. So we need to compare 210 with 180 and Z. So this is our final step. Okay, so yes, Varun, whatever number, you have to assign number. So any number greater than 140 for X, it's fine, okay? So yes, Svetlana, the green point here is that X must be greater than 140. This will be our first condition, okay? The second condition will be Y smaller than delta. And now we need to find the last condition, okay? Svetlana, are okay? Okay, great. So the last condition says that basically here we have, let's see the second box that is fight share, this one. We already have an arrow going out for player B, right? So this one for sure will not be an Nash equilibrium. The box waffle share has an arrow coming in for player B. So we do not want an arrow coming in for player A. And finally, the last box here, share already has an arrow going out. So this will not be for sure Nash equilibrium. So basically, we need to find Z such that there is no arrow coming in for player A. But when is the case when A would prefer to play waffle? Only if Z is greater than 110. So if Z is smaller than 210, then what happens is that we will have an arrow going from share to fight and an arrow going from waffle to fight, because Z is lower than 210. So that A chooses F when B chooses to share. And so we do not have an Nash equilibrium. So again, why we need the Z to be smaller than 210? Because basically if Z is greater than 210, this means that what A would prefer to do, A would prefer waffle over fight and over share, right? So that we would have an arrow going from going in the box. Okay, great. So these three conditions are fundamental to say that, I mean, if these conditions are realized, then we do not have an Nash equilibrium in the game. So again, the three conditions. Okay, Svetlana, no. So basically we already needed A to choose X when B chooses fight. Now we need A not to choose Z when B chooses share. Otherwise we would have a Nash equilibrium. We do not want any Nash equilibrium in any box. Okay? So now what we need is that Z is low enough so that A will not play waffle in the scenario where B plays share. Okay, so this is the reason why we want Z to be lower than 210. Okay? So again, the three conditions that we need to have non-Nash equilibrium in this game is that X is greater than 140, that Y is smaller than delta, and that Z is smaller than 210. Is it clear? Do you want me to go over the analysis again? I leave you 1 minute to think about it. Thanks, Jay. Okay, Saikat, basically my analysis is even more abstract. You can choose a number. The important thing is that the number you choose is like the number for X must be greater than 140. So if you write me X equal 141, Y equal 3 and delta equal 4 and Z equal 209, it's fine. Okay, you can write or more general like mine, or you can just pick a number, but those numbers need to satisfy these conditions. Okay? So for sure in the exam there will be one long exercise on game theory, and there could be a scenario like this one. Okay, so you have to understand the logic behind. Okay, so this was part A. Any other question on this? Yes, Lily, that was an example. Part A was an example of a prisoner dilemma. Okay, so basically for the long question on game theory, what you need to know is how to solve a simultaneous moves game, like in part A, how to modify the payoffs in order to have new Nash equilibria or to change and modify the Nash equilibrium in the game, and you need to know how to solve sequential games. Okay? So here the blue arrow is showing that basically for player B, okay, so blue is the arrow for player B, okay? So the blue one is for player B when A chooses to waffle, okay? So you can put it in red if you want and everything in green here if you want, okay? Any other question? Yeah, the other thing that I suggest you is to use color so that you can see the Nash equilibrium immediately when you do the analysis on this kind of games, okay? Okay, so if you do not have any other question, we go to the sample final version 1 part 3 that is on international trade. Okay? So here we have a small country imports a product that we can call fuel. The country initially allows free trade in this product and the world price is initially PWO equal to 30. As shown in the attached graph, the country has some domestic supply capabilities as shown by SD and has substantial domestic demand for this product as shown by D. For reference purposes, the domestic price would be $80 if there were no international trade in this product. So our graph here is the market, supply and demand. So this supply is the internal, the domestic supply, and here is the domestic demand. And we know that this point is 80. This would be the price in equilibrium if there is no international trade. And this is 80. But in the actual situation, we have a price of 30. This price of 30 is everywhere in the world, so also inside the country. Okay, so the price is 30. So this is what we have from the graph. And now it says in your answer to question in this part, use the attached graph, adding any current label that you need to add for your answer. And assume that there are no externalities from this product. Okay, so it's a basic model where there are no externalities. Part A says, because of changes in market conditions in the rest of the world price now changes to 50. So the price was 30 and now the price goes up to 50. Show graphically and explain the effects of this change in world price from 30 to 50 on producers and consumers of this product in the country and on the country overall well-being. So when the price was 30, what was the quantity supplied and the quantity demanded? So when price was 30, the quantity supplied by domestic producer was QS, and the quantity demanded by domestic buyers was QD. So since the producer were only selling QS units and the buyers wanted QD, basically this part, that is the difference QD minus QS, are the imported units. So basically, initially at the price of 30, they were sold QS units, they were bought QD units, and QD minus QS units were imported. Okay? Is it clear? So this is our initial situation. Now we know that the price has increased to 50. So we need the price to go up. So let's say that the new price is here, and is P prime W equal to 50. What happens? What happens to quantity demanded, quantity supplied, and quantity imported? When the price increases, the new quantity supplied by domestic sellers is Q prime S, that is greater than before, and the quantity demanded by domestic buyers is Q prime D, that is smaller than before. And also the difference between Q prime S and Q prime D has decreased. So basically, as you can imagine, when the price increases, the quantity supplied by the sellers increases, the quantity demanded decreases, and the imports decreases. So when P goes up, we have that QS increases, QD decreases, and the imports QD minus QS decreases. Okay? Okay, so in this situation, we are in perfect competition with international trade. Okay, so no monopoly. So this is what happens to the quantities. So price goes up, quantity demanded goes down, quantity supplied goes up. And now we want to know what happens to the well-being of the agent. So we basically want to see how the consumer surplus changes, how the producer surplus changes, and if there is a loss or a win in efficiency. Okay? So let's compare the consumer surplus before and after the increasing price. You know that whenever you have an increase in price, you also have a decrease in buyer's surplus. So if before, remember that the consumer surplus is below the demand curve and above the market price. So the initial consumer surplus was this triangle. This is the CS when the price is 30. Okay, what is the new consumer surplus when the price goes up to 50? The new consumer surplus is the new triangle above 50 and below the demand curve. So this is the consumer surplus when the price is 50. So what we have here is that consumer surplus is decreasing by this by the area. Let's call this point A, this point B, C, and D. So basically, consumer surplus is decreasing by the area A, B, C, D. Okay, so Varun, not exactly. Yeah, okay, so the area is A, B, C, D. So the area by which the consumer surplus decreases is this one, okay? So we have CS decreases by area A, B, C, D. Okay? So SICAT when the okay, so when the price is 80, but in Okay, so when you are in perfect competition and the price is 80, you have that the consumer surplus is the area above 80 and below the demand curve. What you are talking about is the overall surplus, so the consumer plus the producer surplus. So the consumer surplus is above the price and below the demand curve. The producer surplus is above the supply curve and below the price. Okay? So for now, we're considering only the consumer surplus. So the consumer surplus has decreased by area A, B, C, D. Any question on this? You can also understand why, because you have increased the price. So basically, consumers now are consuming less units of the good because it's more expensive. Okay, so again, the price has increased from 30 to 50. Since the consumer surplus is the area above the price and below the demand curve, if the price increases, the consumer surplus will decrease. So while before the consumer surplus was the area above the price of 30 and below the demand curve, that is the yellow area, now the consumer surplus is the area above the new price, that is 50, and below the demand curve. So it's the blue area. That is the smaller triangle. Okay? Is it clear now? Okay, so Varun, yes, you're going fast. If you do not have any other question, for now, okay, so for now, the loss on the consumer side is the area ABCD. Now we need to see what is, how the producer surplus changes, because the loss is the overall loss. So we needed to see the loss if by chance the producers are taking all the surplus that the consumers are losing, then we do not have any net loss. Okay, so now we need to do the same analysis for producers. So what was the producer surplus when the price was 30? That was the area above the supply curve and below the price. The price was 30, so this was the producer surplus when the price was 30. Okay? Now that the price has increased to 50, what is the new producer surplus? The new producer surplus is the area below the price of 50 and above the supply curve. So it's this new area, the violet one. So this is the producer surplus when the price is 50. So basically, as you can see, the producer surplus has now increased by a little. That is the area AB. Let's call this point E, this point F. So the producer surplus has increased by the area A, B, E, F. That is this area here. So producer surplus has increased by area A, B, E, F. Okay? So the next question is, does the increase in the producer surplus cover the loss, the decrease in the consumer's surplus? So again, the producer surplus is the area above the supply curve and below the market price. Okay? So here, does the increase in the producer surplus covers the decrease in the consumer surplus? As we have seen before, the consumer surplus decreased by area A, B, C, D, but producer surplus increased only by area A, B, E, F. So basically, there is a part of the loss in the consumer surplus that is not covered, and is this area EF, CD. So this is our net loss. So area EF, CD is the net loss. Any question on this? So again, to look at efficiency, what you need to see is how the consumer surplus changes and how the producer surplus changes. So basically in the question, when it says show graphically and explain the effects of this change in price on producer and consumers of this product in the country and on the country overall well-being. So the country overall well-being means that you want to see if there is a net loss or a net increase in well-being. Okay? Okay? Guys, so can you hear me? If yes, can you write me an email saying that yes, you can hear me? Can you still hear me? So you can see my screen. Okay. I don't know if it works like this. Okay, great. So I will continue. Basically, you cannot write in the chat, but it's better than, I mean, here it continues to freeze, so it's better if we continue, okay? So if you have question, you can send me an email, and I have here the cell phone so I can answer the question, okay? So let's go to part B. Okay, so part B says, so basically here again what we did is, what we showed is that there is a net loss. So there is a net loss because the producer surplus increases, but not that much to cover the decrease in the consumer surplus. So now let's go to part B. Part B says, assume that the world price remains at 50. The government of this country becomes concerned about the effects of the high world price on users of fuel within the country. The government is considering a plan to offer a subsidy to imports of fuel equal to $10 per unit of fuel. So basically the price is staying at 50, but the government now gives a subsidy to imports. So here the government gives $10 to who buys from the foreign countries. Okay, so if you buy from your country, you are paying 50. If you buy from outside, you get 40. So clearly what happens is that also the price in the country must go down. So basically now the producer in the country will set a price of 40. And those who buys the Okay, so again, if you have questions, please write me in the email, because here, if I close the program, we do not recover any video for tomorrow, okay? So I don't know what to do. Okay, I'll try to close the program, but I know that we will not have the video for the first part tomorrow.